Endophytes. I'm Matt Powers. Let's get into it. So I'm holding a few different inoculants here that you might recognize, EM and myco, but you may have your own thing. You may be doing IMOs. You may be doing all sorts of things. You may just be doing compost. But all of these things can have endophytes in them. So let's get into it. Let's talk about what endophytes are and why they're so important. Because just the term itself, if you break it up into endo, inside, and phyte, loving, it's an inside loving microbe. So like our microbiome, it's internal to the plant. And the reality of like the Green Revolution is it was a process of killing the soil, a process of killing the microbes in the soil, destroying the organic matter in the soil. And it was really strangely, it was through really alchemy, right? The chemistry side of it really is, the history of that is alchemy. And so they're boiling everything down to these salts, and that's what they applied to the soil. And these purified salts, solubilized, no doubt, but then there are these ions that are purified and hungry. And so they bond to everything and they rip everything apart, because a lot of these things are primary to all organic matter. And so when they're isolated, they attack organic matter and rip it apart, just like synthetic nitrogen, purified nitrogen does to organic matter in the soil. And so it's essentially burning things. And we've experienced things like this when we maybe by accident have trace manure from your chickens, and by accident touch a nose or another sensitive part of your face, and you get like a chemical burn. That's because that is very concentrated nitrogen trying to bond with the organic matter and breaking through the oils of your face and attacking the cells themselves. And so this is essentially what we did to the soil. We chemically burned the soil. And the biology left very early, and it was before we were really testing. So though we talk about the 40s and 50s when things really began with chemical ag tillage, killed fungi a lot earlier, right? And then there were pesticides and there were different things that people were doing in the 1800s that were terribly caustic as well. So there's some prehistory there to that time frame. So you actually have a die-off of biology that began in the 1800s and earlier because of tillage, of course. So the biology itself was not something that we were looking at. And then we had this realization once the organic movement happened and living soil began to be a thing, or Lane-Ingham spread compost, and biodynamics spread, we began to see soils that were actually living soils, so we could actually have plants grow in them that we could study. And our ability to study these plants and these soils has only increased over time. And as that's happened, you've had mycologists, nematodologists like Dr. Lane-Ingham, but mycologists like Dr. James F. White, who have mapped out the rhizophagy cycle. He didn't discover it, a woman in Australia did earlier, but the American team really, by duplicating her research and then iterating it out and making it so that everyone can do the steps, he goes over that. It's like a how-to manual. It's incredible. James White is an amazing person. So we've arrived at this time frame where we recognize that there's microbes in the healthiest plants. We recognize that those microbes trigger immunological responses. We recognize that they're in the trichomes. That's been published now, so I can talk really about it. You sent me. Yeah, so all plants have trichomes, plant hairs, and inside them are nitrogen-fixing bacteria. And so I talked to Jeff Lowenfels today, and he said that microbes use terpenes to communicate to each other. And so increasing the microbes in the terpenes would, and trichomes would increase the terpenes for cannabis growers. And so I realized that they're essentially like cannabis users and cannabis, medical cannabis users as well, are taking in that information of exchange between microbes as their medicine, and that information is modulating how they feel and reversing cancer, stopping seizures, and that's pretty profound. So that idea that these microbes are the actual active agent, but that's what's emergent right now. That's what we're seeing, and it's not just me. You know what I mean? I'm seeing it too, though. That's what's so amazing about Dr. James White, was he not only did it, but he showed us how to do it, and then I went and did it, and I was like, "Is this right?" And he's like, "Yes." And so I've been able to see it because of him, and we all can see these endophytes, and we can do different things to grab those endophytes. Korean natural farming has great preps for getting endophytes. If you think about the bamboo, like they pack rice inside the inner part of bamboo and close it back up and keep it covered, and then they come back and harvest the rice, and the endophytes are now in the rice. That could be adapted to corn, sugarcane, sorghum, so many of these plants, and we know that these plants have these nitrogen fixing bacteria inside them, and we know that there's fungi in the phloem. I mean, you've seen those pictures, right? That I put up where there's those circles where it's bright green, like greener than everything's a little shade of green when we're at efflorescence, but those rings, that's all fungal around the phloem. And so I'm slicing these slices of a root, and we're looking at it, and we're seeing that ring around the phloem, knowing that there's endophytes inside that plant. So, I mean, there's a lot there, and there's a lot we could talk about there. Today you can ask questions. I'm gonna run through a bunch of things that I want to share about endophytes, but please feel free to ask them. So does that mean the nitrogen fixing bacteria in the trichomes are pulling nitrogen from the air? Yes, it does. Yes, it does. So I want to answer all your questions, but I'm probably not going to see them as I'm going through this and riffing off of everything I want to share with you. So forgive me if I miss a question or two, because it comes up like blip, blip, blip and goes away. So if you ask them at the end, and I'll get to them for sure though. All right, so let's keep going. So we have the ability to tell that these things are there. We have the ability to now, and I know that's a very rough way with the Korean natural farming and everything in the rice, because you mix the rice biome from what's remaining in the rice with what's in this other plant. Totally get that. But there are ways that we can isolate things. I mean, there's exudation on corn above ground on those aerial roots. And I already know people that are actually taking that and then using that in their biofertilizers and promoting that and growing that. So this is all active. People are into this right now. There's so many ways to do this. And we're inventing and creating more and more ways, because we're all talking about it from a first principles perspective more and more now, which allows us all together to be participating on the cutting edge of the science. And that's why the database idea came to me. So one of the most important things to recognize is that, like bacteria and fungi, there's a lot of external digestion happening for plant roots. They're releasing these exudates. These exudates are breeding microbes. They're slurping those exudates back up. They're zapping them. And some of them, they're shearing off their coat like sheep, and then they regrow their coat. Some of them, they're harvesting all the way. And some of them put a shield around themselves because they are releasing nitrogen. and it combines with what they're being attacked with to save them and protect them. And so they have to fix nitrogen, release nitric oxide, combine with the superoxide to protect itself. But also it feeds the plant and it triggers it immunologically. So this is, we know the external digestion of fungi, they release enzymes. Plants are also releasing protons and these exudates, which they're carbonaceous, and they're also putting out these protons, these hydrogen H pluses, right? These protons, and so they're putting out this energy, and it's bombarding the particles around it, and those particles are displacing. Well, those protons are displacing what's clinging to those particles, which happens to be other nutrients like magnesium and other cations. And if it releases hydroxide, it releases anions, right? And so this is what they're doing. That's kind of like an externalized digestion, right? They're sending something out, but they also have an internalized digestion, different from bacteria and fungi. They have an internalized digestion, and that means they have a microbiome. And so just like us, they have these microbes that help regulate their systems. And there's a lot of studies that show very incredible things. We have endophytes retasking, fusarium wilt to do beneficial tasks instead of attacking the plant. We have examples of endophytes just making the plant more resilient. We have examples of endophytes releasing things that we would think were the plant's secondary metabolites, like the terpenes or something like that, but they're actually from the microbes. This goes back to radical mycology's Peter McCoy telling me privately, being like, well, Matt, I actually think that, it's the fungi in the plants that's actually the medicinal component. And this is like, it creates that, and so in that way, it's an extension of itself, right? But we've all been chasing this because it's been in development. And now we can track these things. Now we can map these things, and we've got all the different stains that allow us to capture the different exchanges. So you can do isolations of different microbes and grow things in such a way that you could have just the seed in like a hydroponic kind of situation, and just be having it with that one microbe in distilled water, that's pH, right? And you could actually map the process and see like the inoculation rates and like all that. Like we actually can see all these things, and then we can start connecting the visual IDing on a microscope to that actual bacteria. And then once that's mapped out, we can start working on, machine learning recognition, and then the sky's the limit, because then we can just have these things be read, and then that has us do more testing because we get more value out of it, and it makes it easier on us. We don't have to do all that work, and that changes like the entire landscape of the science. So that's really, really what we're after, because if we have a better understanding and more fluent understanding of how these things are all working and who's who and what proportions, and we've begun the process. It's definitely begun, and that's why everyone's so excited. But once we can do it in a much more transparent and open way, it's going to be amazing. And so the thing is, there's an externalized digestion, there's an inner digestion, and there are members that are part of it all. So they're the feedback loop. So there are decompositional microbes and saprophytes, right? That break down dead, dying, decaying organic matter. That's like what, EM does. But then I can drink this too. And we can use it in the compost, and I can use it in my irrigation for my plants. I can use it in the irrigation canal where there's algae and take care of the algae. All of the above. And so this feedback loop, though, these members have all these thousands and hundreds of thousands and sometimes millions of different strains and species, really ways of expressing themselves, I would say, because a horizontal gene transfer allows microbes to literally dump genes and take up genes from the environment, from other microbes, and through viruses. That causes them to adapt rapidly, much more so than reproduction and evolution traditionally has led us to believe. It's actually the dominant is in microbes and bacteria, is actually horizontal gene transfer. All those three processes: the dead, the conjugation when the two microbes are going like this. Like this happening like crazy. This is kefir right here, water kefir. And this is happening like crazy right here. These are two right there in a passionate lover's embrace. That's literally what they're doing. It's conjugation. And then there's viruses, mu viruses. They're tiny viruses, and they're in everything that I find that has bacteria in large amounts, because it's one of the pathways that things get communicated between them. So 60% of what touches our skin goes in is something that Antoinette Marquez like drilled into my head, but it's also the same thing with like leaves and roots. There's this absorption happening between microbes, but there's absorption happening between the roots and the air, and everything's in constant exchange. These boundaries that we see that look so like hard, they're not. They're actually quite porous, and there's constant communication happening between them all. So these feedback loops are incredibly important because, well, let me talk about something first of all about who they are, because they might surprise you. In just this, for instance, in EM, effective microbes, Terraganics is a great supplier of this. In just that, you've got Saccharomyces cerevisiae, beer yeast, and baker's yeast. It's the same thing. And of course that means like, yeah, so we used to all just put things out on the windowsill and capture the wild yeast. So this is like a select wild yeast that we selected for a long time ago and have been using this whole time. It's in all the plants already that they've tested. It lives inside the plants. And what does it do, right? Well, what's it doing in there? Oh, it as I thought about it, it occurred to me, and no one had ever like told me this before, but because it eats sugars and it eats simple sugars, it's helping balance the sugars in the plant. So when you think of the plant, you know, the actual pyramid, the plant health pyramid, John Kemp, and it's like, got to take care of your monosaccharides into polysaccharides, your simple sugars into long chains. That's what the beer yeast can do. So it's a way of them actually balancing the sugars they're creating through photosynthesis. So on those hot, sunny days where it's just do, and they're just like, whoa, okay, whoa, we're photosynthesizing, and they might not have enough minerals of varying sorts to go through all the different processes to have those polysaccharides. So there might be missing, you know, almost anything they could not have enough of. And that's why we often do broad spectrums like kelp and compost to hit those deficiencies, because things change every micrometer in the soil, and unless you've got a very connected, living, vibrant soil, things aren't being transported readily across inches, feet, or even dozens of feet or hundreds of feet. Those things are possible, and they've been documented, but most of us don't have soil that developed yet. And I've seen it. I've seen, you know, incredible systems that are vibrant and fully connected. But this is often a new idea for people. So purple nanosulfur bacteria Rhodocytomonas palustris. This digests sunlight, CO2, oxygen, sugars, and organic matter. So it's a versatile decomposer. And it's found in manure lagoons. And it's because it's so versatile at breaking things down, and because it's a nitrogen fixer, and because it's an endophyte, it can occupy all those areas. And we don't know exactly, I don't know exactly where it comes into the equation. Like, people are saying it's from here, people are saying it's from there. I've got to DNA test things and track down exactly where, if it's all of that, it's probably all of them, but variable rates, of course, right? So I want to figure out which is the best. And testing is how we discern good, better, best. Like, that's the reality behind everything I've learned in the past 10 years, is the only way. And we've also seen that play out, like, in the cannabis industry. The way they've just been started to be just open, vulnerable, sharing, testing, that whole thing, and their contests, their cups, that drives greatness. They challenge each other to be greater and greater, and try best practices out and stretch them, and that helps them discern good, better, best. And that's the same with that kind of thing I want to do with the Our Soil database, and we will be doing, because the Kickstarter is fully funded. And so the reality, though, is every person that joins causes an exponential growth in the amount of information, the amount of insight. And over time, all those entries are going to have huge impact. Because even if you just did your soil mineral tests and just entered those in, or even if you were I'll map the database from the microbiometers results across bioregions, I'll fill in the fungal to bacterial biomass for all of that. The correlative information, as people themselves put in those two tests together on their own thing in your bioregion, within your pH range, with the organic matter range you have, across those bandwidths, you'll be able to start seeing correlations. And then as they start fleshing out, we have thousands, hundreds of thousands, and millions of tests over time, that will actually, your one test will have all these correlative insights. And so you'll be like, wow, for my bioregion and for my soil type, I really should pay that extra for that test, that for aluminum or for lead or what have you. But think about in the past 20, 30 years, we find out about these ecological disasters and these contaminations of things so late. And it's always citizens bringing it up. It's always citizens forcing it through. It's like individuals, brave individuals, whistleblowers, all these people who brought attention to ecological disaster and crazy pollution and contamination. And only when people have forced and attacked those people have they gotten results. And so it's like, we have to take care of ourselves. We have to be the citizen scientists and the community laboratories. So pooling resources, maybe our local nursery, so that's a community gathering spot. Maybe our local Mycology Society, right? The Central Texas Mycology Society is one of the most incredible organizations I've ever encountered. And they're doing incredible work and empowering so many people. And they're developing their lab, and I'm helping with that. This ability for us all to have more accurate testing by getting multiple forms of test results is so critical. It's so critical. I mean, just doing 2 or 3 tests, not just one, allows us to triangulate and figure out whether the results we got from the one of that original test was truly accurate. And we can also infer things like, oh, we're open to possibly this thing happening, this disease happening, or It's obvious that like things have been waterlogged. All those kinds of things, they jump to the fore when you do things in combination. And you're like, wow, so the next time it rains, it's gonna do this. We need to make sure we reinforce and we add. And so this type of dynamic response diagnosis is absolutely possible. But continuing on with individuals, like lactobacilli, a lab that digests nitrogen. That's another step in the plant health pyramid, John Kemp. So in other words, dealing with excess nitrates, huge stressor on plants. And so the ability for plants internally to digest the nitrogen is also incredibly important. So these plants, these microbes are in if we throw this into the equation, right? So this is ectomycorrhizae, endomycorrhizae, rhizobacteria. So these are coating the roots, and endomycorrhizae and ectomycorrhizae go into the roots. I know there's a lot of confusion around this. Folks are like, oh no, ecto's on the outside of the roots. No, they both go into the roots. They're on the outside of the cells. So they ensheath the cells, but they're inside the roots. And then the endo, remember from endophyte, inside. But it doesn't actually go inside fully. It goes inside the cell wall, but not the cytoplasm of the cell. Huh. So it's kind of tricky. It's a little bit strange, but it's very cool. I've got diagrams of it, and so the reality is that these and the reality is almost everything is endomycorrhizae. Ectomycorrhizae is much more specialized. It's like 6 to 8% of plants, and it's like woody tree species and like timber species, and not like fruiting like plants. So endomycorrhizae is the one that like we want, right? So that's arbuscular mycorrhizal fungi. They're like functionally the same. And terminology is constantly changing in this area. That's why, rhizophagus is glomus. If you go back farther enough, or if you're with certain companies, they haven't changed or updated. It's funny because some people, sometimes older folk, value like what they were taught, and like that's the way it is. And because of the genetic testing, it's created a situation. And I understand that. I respect where they're coming from. It worked back then, but now because DNA testing, we have so much. We've got like uncategorized categories and groupings of fungi because the genes showed us that our eyes were tricking us. So. And then there's rhizobacteria in here, like Inoformis, Pamillus, Subtilis, and Megatherium. Subtilis is one that, be careful with, wash your hands. Megatherium, that was a model organism in laboratories. So they go in the rhizobacteria. Endophytes are also, like I said, able to fend off attack. So when rhizophagy is happening, when the plant is putting out exudates and then slurping them back in and destroying all the microbes in there, and that's actually how they grow their plant hairs. The root hairs on plants only come from the rhizophagy process. So there has to be microbes there for it to actually happen. So if your plant doesn't have hairs on their roots, when you look at it under the microscope, it is because there's no microbiology. So you need to have the microbes there in order to have plant root hairs. So endophytes are the ones that persist. They're the ones that remain, and they're the microbiome. They're helping the two most fundamental core processes of the plant, dealing with their nitrogen synthesis and their carbohydrate digestion into polysaccharides. So they're doing photosynthesis, they're generating these monosaccharides, and they have to turn them into polysaccharides within the 24 hours of their cycle, or sun comes out again and they begin again. And then they're like stacking up, and they're like, ah, and then they die. And well, they call in a pest, right? They call in a disease, something that will help turn those sugars quickly into other things and help them reproduce. And so, a pathogen comes in and starts using those excess sugars to reproduce. That's what happens. So, there are endophytes in the roots living there. There are endophytes living in the phloem. There are endophytes living in the trichomes. There are endophytes living on the leaf surfaces, inside like inside the leaves, but also they're all over the surfaces of the plant as well. Like Elaine Ingham talks about how the plant's enfortressed with microbes. Yep, absolutely. It's very interesting. You'll see on some of the images that I've put out where the stomata are glowing bright with fungi, and so everything's red. Well, because chlorophyll is red in the epifluorescence, so we know the photosynthesis is happening with this leaf. So it's all red, 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 and then boom, bright green stomata flaring light at you, and you're like, whoa, all of these leaves are doing photosynthesis strongly, and their stomata are fungally inoculated. And I can see that instantly with this setup. And then this internalized, externalized digestion was completely missing from that green revolution, because that was really about sterility and control. And ultimately, the farmers thought it was about control of nature, control of the soil and their plants, but it ultimately became control of the farmers themselves by these companies. And this whole idea of a sterile growing medium, this idea of sterility, means that the plant has no immune system. Imagine if we sterilized your digestion. Nothing would digest. Food would pass through you like sandpaper, it'd be horrific. And so without microbes, we don't digest the food and get the energy out of our food. The plants are the same way. So in other words, you and I are living in the era of the return of living, like living microbiomes in plants. We are living in that revolution beginning right now. And the beginning, the little beginning was like the 90s and the aughts and the 2010s, like compost, all the biofertilizers, Mycorrhizae, they were introduced in that time period. Now we're putting them all together for the first time. I mean, my book Regenerative Soil combined like the biology and the minerals, and people were like, this is amazing. They never combined the chemistry and the biology. It's like, we are there. We're just beginning the process. And so the endophytes, there could still be some missing. And I suspect there are. So one of the things we're going to do with the database is I'm going to encourage people to test natives in wild areas, and to gently take root clippings, not taking up the whole plant, excavating, root clipping, returning. But I suspect that there's actually biology that's completely missing this is why, okay? When I did all the research for this, I'm finding research on all these microbes about their history, and you'll read about it in that book if you have the book. So many of these microbes have pasts, and they're industrial microbes now. and they were just extra large, ubiquitous, and we had no idea what they were. And we just figured out what they could do, and then the biochemical industry essentially just hijacked them and like enslaved them for their own purposes, right? So like Aspergillus niger makes like citric acid, right? And that's the majority of citric acid used in things. Black mold, in other words. So it's, we really need to recognize the power of these microbes and then do a lot more observing and discussion around what's possible and discovery work. So we need people to be, because the wild thing is there's no funding for this sort of thing, and it can't be like commercialized, you know what I mean? It's wild, it's naturally occurring, right? But that's the exact point, because that's the natural landscape of their digestion that they had in the past, and we stole from them, and now we only discovered it like through happenstance as we brought these other elements back in. They came in with it. So like rhizobia, right? Rhizobia was always in the manures because rhizobia is part of the digestion inside all ruminants that eat legumes. So the nitrogen fixing nodules on legumes are in the plant. They get eaten. They are part of the digestion, and they return in the manure. And so when we add them to our compost, add them to all the things, we were adding those in. So, and that's something that, you know, I was able to recently map out myself with DNA sequencing myself. There's no other, and I've proven it out over a dozen times. So I know that it's true. They survive the hot composting process. They're in the manures. And so when we do hot compost, whether we're using like alfalfa and a bunch of clover grass, right, or for our nitrogen, or we're doing manure, we are getting the rhizobia in there. It's ubiquitous. So it's really a fantastic thing to be able to track those things, to be able to connect those things, but we really are just at the beginning. And we in this process of mapping it out, though, we can understand what we're looking at, and we can share and map out the commonalities and differences and patterns. And so much of this is good, better, best. So much of this is identifying patterns. So much of this is sharing things. Because there's so many, we already have dozens of tests, and we already have, just talking about microscopy, we already have dozens of tests. But I went down to the principles behind the tests. And in science, as you know, you have a hypothesis, and you design a test to test that out, and then you develop theories, right? The principles behind all those tests are the same. Just like there's like principles behind bacterial counting, and every lab has their own method, and the logical count method is something I used as the basis for mine, which is the most common lab counting method. So there's so much. There's so much still to be seen and shared, but if you guys have the keys to the car, if you have the tools and the understanding to participate at the fullest, you will find things, you will see things, and we will all connect things that have never before been seen, never before been mapped. And so, and I know this because I've consistently in the past 6 months discovered new things, shown new things, and people who have been doing this for 40 years, you know, are excited and want to see what I do next, and use and partner, and it's really wild. And that's why I want to do it in a transparent database to organize all of my work. Because I want to do as much work as possible, and organizing it just by names and in boxes and folders is terribly inefficient. It's a mess. And that's what everyone who's a soil consultant has shared with me. And so this is going to be a way that we're going to be able to organize in time, type, have multiple ways of categorizing things, and then to be able to search things and to run comparisons against over a dozen different variables for free, and then hundreds of variables. And maybe at first it'll just be over 50, but it'll be, I mean, once we start doing DNA, right, we'll be able to do individual microbe searches. And so you'll be able to find all the compost with that type of microbe, and then you'll be able to look at the feedstocks that went into that compost. And so you're going to be like, oh my word, Bokashi with these ingredients creates these microbes, and it's the only way to do it. Nothing else has ever mapped out this way. And we're going to find that. There will be things, combinations of things. Of course. I mean, think about this. When I was a kid, I didn't know this, but when I was an adult, I started hearing that they'd never tested a lot of things against each other in a laboratory settings. So like the FDA will test like Tylenol by itself and do all these tests and everything, but they'll never test like Tylenol with this. They find that out by like someone having Tylenol with this and having a terrible reaction, and they're like, oh, we'll put a warning label on there for that. You know, and like that's how they find those things out. And so combinations of 2 to 3 things, combinations of 3 to 4 things, you know what I mean? Like those kind of relationships you can only figure out with a large data set and as many data points as possible within that data set. So we're gonna be able to do that. And I want it like a library, so you could look that up, regardless of whether you're a member or not, so that it becomes a resource that all the universities want to use, all the research scientists want to use, all the farmers want to see as their benchmark, because they're looking up their organic matter compared to the other guy in their bioregion going, what is this compost like? What is he putting in it? Martha, we need alfalfa cubes. You know what I mean? So that kind of change, though, that's pivot power. That's really how we're going to help people change, by making things self-evident. And endophytes are one of those things that's going to change everything. That's new, that we're still mapping out. And what we've discovered has been absolutely amazing. And we're going to always discover the obvious ones first. We're going to discover the ones that are like beer yeast and inside all plants that we find, you know what I mean? Right? But there's going to be more. And so our explorers in the old growth forests, our explorers in the wild grasslands of the Midwest, or the jungles of the Amazon, or the desert, oases. Like all these areas are going to have this very, very special biology. And mapping these things is going to really help us understand a lot of things. I mean, we may find certain microbes in really weird areas doing things that we don't expect. And it could be the horizontal gene transfer environment influence, and they're taking up the genes that are there. Because hold on, genes, DNA, can last theoretically up to millions of years as it breaks down. Horizontal gene transfer can take up dead DNA. It appears that 40 to 50% of all, the 39% to 41% is always unclassified. And that's likely fragments of DNA. And that's why they can't diagnose it. But that means that soil is in a large part just as infinite potential of all the past. So it's fragments of fungi, bacteria, all the different microbes, all the different animals and plants that have died there. Their genes are they're in pieces in that unclassified section. And then the reason I said up to 50% is because there are these genes that we share with everything that translate and travel through everyone and are constantly traveling. They're mobile genetic elements. And I think that in the soil, they're classified as human. And so I need to interview Minayan more on this. It's fascinating though, because it's like you wade through for a year, you wade through all their different like experts, and then like you finally arrive at like someone who's like obviously really knows. And I've been talking to that person lately. And so a lot of these things are semi-understood. They don't know why certain things work the way they work. Why is fungi so indestructible? We spend 2 days bombarding these things and we still can't break the DNA of fungi. Well, this is why it can go out into space and come back and then spore and then create itself again. It can sporulate and keep going. This is why if a giant meteor hit the planet, all the spores that survive that, and many would survive that process, travel through space, land on another planet that has water and heat and oxygen, things would begin again. It's pretty wild. That's what the whole mycogenesis theory is. So what questions do you guys have? I have 4 more days in the Kickstarter. It's going so amazing. Thank you all for your support and for sharing it. We have 4 more days. It ends Sunday at 8 a.m. I know it's a bizarre time. but that is what it is. So yeah, Saturday's really the last day. And I'll be doing a webinar on Thursday, privately live over Zoom, and I invite everyone to that. I'll be putting links for this later on today, out and about. I will be on Smiley's Garden later. I think it's Smiley's Garden, but Smiley's podcast tomorrow night. And I've got a bunch of videos planned. Jeff Lowenfels and I, the author of Teaming with Microbes, Teaming with Fungi, Teaming with Nutrients, and Teaming with Bacteria, he wrote a book about rhizophagy. So it was really, really interesting. He knows my work, and he knows James White's work, and so he had to create a response. And in the conversation, he started talking about doing other revision work to the fungi chapter after I brought endophytic fungi up. So it was amazing. It was a lot of fun. So I'm going to be sharing that tomorrow. So tomorrow, Jeff Lowenfels. The day after that, I'll have the New Revolution in Soil Science webinar. Friday, that'll be a replay on here, but there'll be a live Q&A. So I'm gonna just unveil a bunch of crazy things and talk about what's the potential of where we are right now. I was talking to Jeff about it. It feels like there's like this paper thin wall, it feels like we've been digging a long time, and we're in a tunnel and there's this wall, and I know if we just hit it a certain way, or if we just dig it just a little bit harder, a little bit faster, we're just gonna break right through. I mean, we were talking about the relationship to the gut. He needs to talk to David Montgomery about something, about the lower intestine related. Like we're all talking behind the scenes of all the soil people. We're all talking behind the scenes. And there's a lot that's bumbling and fermenting. Zach Bush, we talked about Zach Bush and how incredible it is to see that side of things developing. We're so close to connecting all these pieces. That's why this Kickstarter is so important. If you guys have any questions about endophytes, please add them right there, or later on, I'll kick that over if, but later on you can add them in the comments too. Thank you all for being part of this community. Thank you for subscribing. If you are interested in this Kickstarter, now is the time to join us. Click the link below in the description and join us, because this Kickstarter, it's my most popular Kickstarter I've ever done. This has been my most successful Kickstarter I've ever done, and it's totally blown the Regenerative Soil, the first book in the trilogy, out of the water already. It's absolutely incredible, and I think it's because of this the database. I think it's because of the fact that we have not just bright field, but we have epifluorescence, we have polarized, we have dark field, and we have the light field technique. So there's so many new ways to look at things, so many new ways to take the same exact slide and image and then view it in multiple ways. Combine those images even and visualize things in a much more accurate, much more insightful manner. And so many of these different wavelengths, so many of these different ways of visualizing allow us to have like an immediate assessment that allows us to it's not like tedious. It's not like we're counting the bacteria to calculate the fungal, the bacterial biomass. This is there's a lot of these wavelengths that allow us to give instant assessments. Like you can see if it's inoculated, and you could do the calculation to figure out if it's 2040. But we'll have tools to make that all calculated for you in the database. Members are going to have tools to make it a must-have for every soil consultant, every soil research lab, so that with every usage, it's going to be training it more and more and getting better and better, and then it's going to be able to read it itself, and we'll be able to just put in the actual image. This is the future. Thank you for being part of it. I'm Matt Powers. Grow abundantly, learn daily, and live regeneratively. I love talking about endophytes. They're the missing piece in so many of our systems. They're the missing digestion of the microbiome of plants that has been gone for so long. So thank you for learning about it. It means so much to me. I appreciate you all. Have a good one. All right.